Welcome to The Explainer. Today we're going to tackle a question that sounds, almost like a riddle, but trust me, the answer will take us on a journey that completely reshapes how you might see, well, everything. All right, let's jump right in.
It all kicks off with this simple puzzle. Why would a boat on the East Coast fall apart so much faster than one on the West Coast? Now you might be thinking it's salt water, right? And yeah, you're not wrong, but that is just the beginning of the story. The real answer takes us from ocean currents to the very rules of the universe.
So to crack this puzzle, we've got to start with the ocean itself. You see, the Atlantic and the Pacific coasts are living in two totally different worlds, all because of the water. And that, right there, changes everything.
Okay, so here is the first major clue. The East Coast is dominated by the Gulf Stream. Think of it as a massive, fast-moving river in the ocean that's super warm and packed with salt. Now, the West Coast, it's got the California current, which is pretty much the polar opposite. It's cool, it's slow, and it has a lot less salt. This one difference creates a huge domino effect.
And here are those dominoes falling. First, warmer water just makes things rust faster. Basic chemistry. But it's more than that. The warm, salty Gulf Stream pumps all this moisture and salt into the air. These tiny salt particles, they love water. They literally pull moisture out of the air, acting like little seeds for fog and, you guessed it, thunderstorms. It's not just weather. It's a weather machine that fuels itself. And what you get is something meteorologists have a great name for, a baroclinic zone. Seriously, just think of it as a weather battleground. You've got this cold, dry air coming down from Canada, constantly smashing into that warm, wet air from the Gulf Stream. And that collision, that's what creates those wild spinning storms like nor'easters. It's a total demolition derby in the atmosphere. But here's where we pull the camera back, way back. Because that spinning storm, it's not some random event. No, it's actually a perfect example of a hidden pattern that nature uses, well, pretty much everywhere.
And it all comes down to this one mind-blowing idea, the spiral. The corkscrew shape. It turns out that is the single most efficient way to move energy or matter from point A to point B. Nature, all by itself, with no instruction manual, figures this out every single time.
And you see this exact same shape at every conceivable scale. I mean, from the epic swirl of a hurricane or an entire galaxy, down to water spiraling down your drain, to a bird effortlessly riding a column of warm air, all the way down to the code of life itself, the double helix of our DNA. It's the same shape, the same solution.
This quote just nails it. These things are spontaneously forming machines. There's no engineer, no blueprint. Just give it a difference in energy, like hot and cold air, and the system will automatically build itself into this perfect spinning machine to sort it all out.
Okay, but this is where it gets really strange. This leads us to a massive paradox. Because, it's one thing to notice that this spiral happens. It's something else entirely to ask why. And that question, it changes everything.
I mean, really think about that for a second. Air molecules don't have brains. Water droplets aren't sitting there with calculators trying to find the optimal path. So what is it? What force or law of nature pushes dead, dumb matter to consistently find the most elegant, the most efficient solution all on its own?
This question basically forces us into a corner. We have to choose between two totally different ways of seeing the universe. The old-school, mechanistic view is that everything is just a chain reaction, right? Billiard balls hitting other billiard balls. The past causes the future. Simple. But this new view, the optimizing view, it suggests something else. It suggests that systems are almost being pulled toward a goal, toward an ideal final state, as if the future itself is reaching back and shaping the present.
It's kind of like the sunglasses in that old movie They Live. You put them on and you see the world for what it really is. Well, once you put on this optimization lens, you can't unsee it. The old idea of a simple clockwork universe, it just feels wrong. It's like mechanism is dead.
So looking through this new lens, you start to notice something else. Nature's solutions, they aren't always clean and elegant. A lot of the time, they're actually kind of weird. Clunky, specific, cobbled together solutions. They're less like a perfect design and more like a series of really clever hacks.
And some of these hacks are just bizarre. Take photosynthesis. It's not just simple chemistry. It uses a quantum trick to check all possible energy pathways at the same time to instantly find the best one. Or birds. They seem to use quantum entanglement, that spooky action at a distance Einstein talked about, to literally see the Earth's magnetic field. Even a gecko climbing a wall is using a weird quantum-level stickiness called the van der Waals force. These aren't grand universal principles. They're weird, specific hacks that just worked.
And this leads to a really cool comparison. Think about systems we humans design. They follow clean, pure logic, but that often makes them brittle. One wrong input and the whole thing can crash. But nature's evolved systems, they're messy, they're ad hoc. They're like that ancient piece of software that no one dares touch, but that somehow never ever fails. Why? Because all the knowledge, all the wisdom isn't written down in a manual, it's baked right into the messy, resilient structure itself.
So, if the universe isn't a simple machine, and its solutions are these strange, messy, resilient hacks, then what is the point of it all? What's it for? This brings us to the biggest question yet, the ultimate why.
And to answer it, we have to go all the way back to the beginning. Back to that spinning storm on the coast. We saw it as a machine. But now, with everything we know, let's look at it one last time.
For a long time, we've basically pictured the universe as this epic battle between two forces. On one side, you have order, building things up, creating structure. On the other side, you have entropy, breaking everything down into chaos and randomness, a constant tug-of-war.
But that's not what the storm is telling us. It's not a battle at all. It's a dance. The storm doesn't choose between hot and cold air. It needs both. The very difference between them is what powers it. Order and entropy aren't enemies. They're partners. One creates the conditions for the other.
So if the goal isn't just efficiency, what could it be? This leads to a truly wild idea. Let's call it the experience principle. The theory that the universe isn't just optimizing to get a job done, like moving heat around. It's optimizing to create the most varied, the most diverse, the most interesting set of experiences possible.
And suddenly, all those weird hacks make sense. Photosynthesis, the bird's compass, the gecko's foot. Maybe they're not just solutions to problems. Maybe each one is a brand new, totally unique way for the universe to know itself, to feel what it's like to be a plant, or a bird, or a gecko. The point isn't just to survive. It's to collect every possible way of being.
And that, of course, leaves us with one last question, a personal one. If the entire cosmos, from the smallest atom to the largest galaxy, is a vast engine for creating and collecting experiences, then what about you? In this whole cosmic library of being, what unique, unrepeatable experience are you adding to the collection? Thanks for joining us.